All right, let's start with a question you've probably never asked yourself while getting ready in the morning. What does engineering, the science of bridges and computer chips, have to do with the t-shirt you're wearing right now?
The answer? Well, it's pretty simple, and it just might change how you see your clothes forever. The answer is everything.
To really get why, let's go inside a garment factory. But I want you to forget any idea of a nice, clean, quiet assembly line. Picture this instead. Hundreds of sewing machines all humming at once, mountains of fabric being rushed from one station to the next, and this constant, looming pressure of a deadline. It's basically organized chaos. Now, this kind of chaos isn't just stressful. It has very real consequences. It means you have overworked, exhausted people, which naturally leads to mistakes and inconsistent quality in the very clothes we buy. It causes constant delays, makes costs totally unpredictable, and creates these huge pileups in production, what experts call bottlenecks. So, how in the world do you bring order to all of that chaos? Well, it turns out there's an entire field of science dedicated to doing exactly that. It's called industrial engineering. Now, that might sound super complicated, but you can really just think of it as the science of efficiency. It's the art of looking at a big, messy system, like our t-shirt factory, and figuring out how to make it smarter, faster, and honestly safer and better for everybody. So, if you're an industrial engineer or an IE, where do you even begin? Well, it all starts with the most important part of any factory, the people doing the work. This right here, this is the golden rule. If you try to force a person to adapt to a poorly designed machine or chair, you're just asking for fatigue, strain, and mistakes. So the whole goal is to flip that around, to engineer the job itself so it fits the natural, comfortable movements of a human being. This area of study is called ergonomics, and it's a huge tool for an industrial engineer. They'll analyze every tiny movement a worker makes, every time they reach for a piece of fabric, every turn of their body, and they use all that data to design workstations and workflows that actually reduce stress. Because think about it, a comfortable worker is always going to be a more productive and a more accurate worker. Okay, so once the work is safer and more comfortable, the next massive challenge is time. I mean, in a factory, every single second has a dollar sign attached to it. This is the big question an IE has to answer. And it's not about making people work faster or rushing them. It's about figuring out a fair, consistent, and totally achievable time for any given task so that you can plan everything else around it. To do this, engineers use a method called an operation breakdown. So instead of seeing sewing a sleeve as one big job, they see it as a series of tiny little micro movements. They time each one of these little steps to build a super accurate picture of the whole task from start to finish. And the result of all that detailed study is a single number. It's called the SMV, or Standard Minute Value. This is the benchmark. It's the scientifically proven time that a trained worker should take to do that one job. And it's what factories use for everything from setting production goals, to calculating their costs, to making sure people are paid fairly. So, now we've got workers who are comfortable and tasks that have a standard, predictable time. The next step is to make sure all those different pieces flow together smoothly, like a symphony instead of a traffic jam. This is the huge challenge of what they call line balancing. Just look at the difference here. On the left, you've got an unbalanced line. Worker A is completely overloaded with work, creating that bottleneck we talked about. Meanwhile, worker B is just sitting there waiting for work to arrive. It's a disaster of inefficiency. But on the right, that's the goal. A perfectly balanced line where the work flows smoothly and everyone has a steady, manageable pace. So, solving these really complex puzzles of people, time, and flow, it obviously requires a very specific set of skills. But how are those skills actually taught? Well, the university syllabus that inspired this whole explainer gives us a really cool peek inside the training of a future industrial engineer. Yeah, becoming an IE is no joke. A massive chunk of a student's grade, we're talking 65%, comes from these huge exams that test all the complex theories. But it's not all just about what's in the textbook. A huge part of their training is actually super practical. They're constantly being evaluated through class tests, assignments that might involve analyzing a real factory, and even presentations where they have to sell their solutions to others. This is where all that theory really meets the real world. And, mastery doesn't just happen overnight. This whole journey is a step-by-step process. They start with the human factor, ergonomics. Then they layer on time studies. By just week 6, they're already trying to solve line balancing problems.
Each concept is a building block leading up to those big exams and presentations where they have to put all their skills together to solve one big problem. Because in the end, that's the whole point, right? The goal is to graduate students who can walk into that chaotic factory we started with and not see chaos at all. They see a complex problem that they have the exact tools they need to solve. So the next time you pull on a simple t-shirt, just take a closer look. You're not just looking at cotton and thread. You're looking at a product of ergonomics, of precise time studies, and of carefully balanced production lines. You're looking at the hidden and pretty amazing world of industrial engineering.